Welcome to the beginning of your journey into geometry. We're going to start by talking about some basic geometric shapes. We are going to start by grouping these shapes into categories based on this idea of movement and how much you are either allowed or not allowed to move when you are on one of these objects. So the first category is objects where movement is happening in no directions. You cannot move anywhere in space when you are on one of these objects. You could be stuck right here on that object forever, or you could be stuck right here on this one, or you could be stuck right here on that one. When you are on one of these objects and you can't move at all from it, that means this object has no size, and there is nothing to measure about this object because you can't go anywhere. You're stuck here, or you're stuck here, or you're stuck here. Since you can move in no directions and it has no size and there's nothing to measure, we call these zero-dimensional objects. But more commonly, you would call these points. And in order to tell this one from this one from this one, you would give them names. Like you could say this one is A, this one is P, this one is R. And then I'd be able to say, go to point P. And you'd go right there, and you'd stay there, and you couldn't move from that point. Something I just want to make really clear, and I'll try to emphasize it as we go through these other shapes, or these other objects. A point is an object, again, that has no size. So if when you're drawing it, you happen to make this point look kind of big like that, that is just an illusion or part of your illustration to make this point look bold and stick out. Point P is not bigger than point A. All points are the same size, which is that they have no size. So you can't talk about one point being bigger or smaller than the other. The next category is if you are allowed to move in one direction. In this case, if you are moving in one direction, you have length. And if you're moving in one direction, we're going to call you a one-dimensional object. There are three categories for these one-dimensional objects that all have length. If that length is infinite, that could happen if your object has no starting point, no ending point, and it just goes on forever in each direction. Or your length could be infinite if your object starts at one point, takes off in one direction, and then keeps going on forever and ever. Or you could have one of these objects. And in this case, you have finite length. So infinite means it goes on forever. Infinite, it goes on forever. It has infinite length. Finite is the opposite of that. It doesn't go on forever. It starts and it stops. One of these things, this is called a line. One of these is called a ray. One of these is called a line segment. Or more commonly, you'll just say the word segment. And for all of these objects, every single bit of it, we'll say like every bit of a line, a ray, or a segment is a point. So even though there are none that are bolded on here, every bit of pencil that you see on this line is a point. Every bit of pencil you see on this ray is a point. Every bit of pencil you see on this line segment is a point. And if one of the points was special, then you might bold it to make it stick out a little more. Like if we were talking about a line, and I happen to know that that line passed through a couple points for which I knew the name of them, I knew their names, then I might bold those points so that they stick out. But just because this one's bold and this one's bold and this one's bold, it does not mean that there are 3 points on this line. There are infinite points on the line. There's a point there, there's a point there, there's a point there, there's a point there, there's a point there. That one I happen to know the name of, so I made it bold so that you notice it. Lines have no start, they have no end, they go on forever in each direction. And when we name them, if you happen to have a couple, you happen to know the names of a couple points that the line goes through, you have a couple options for how you're going to name the line. This line that you see here could be named AB, because you're saying I'm a line, that's what the symbol means, and I pass through the points A and B. Or you could say this line here passes through the points B and C. Or you could say this line passes through the points A and C. Or you could say this line passes through the points A, B, and C. All of those are valid ways to name this line. A ray, yes, it has a start, but no, it does not have an end. So a ray starts in one spot, takes off, and goes on forever. And if I knew this point's name, I might bold it. If I knew this point's name, I might bold it. And if I knew this point's name, I might bold it. When you name rays, you have to pay attention to where you're starting and where you're going. So in naming this ray, I'd have a couple options due to the fact that there are 3 points I know the name of. I could say start at A, go to B, and keep going. Or I could say start at A, go to C, and keep going. Or I could say start at A, go to B, then go to C, and keep going. But if you said, so this is good, this is good, this is good, but if you said start at B and go to C, that would mean you start here and you shoot off towards C and you keep going. That's a ray that exists, but that's not this ray that's drawn in the picture here. So this would not be a correct name for the ray that you see here. Or you could say, I see the point A, I see the point C, so I'm going to write CA, and it's a ray. But when you interpret this, this is saying start at C, go towards A, and keep going. Start at C, go towards A, and keep going. And that's not what's happening here. So this is also not a valid way to name this ray. And the last of the 1D objects that we'll talk about here are segments. Let's talk about segments. So segments, yes, they start, and yes, they end. This segment that we're going to draw here, let's say it started at A, this was point B, and this was point C. Depending on which combination of letters I use, I could refer to different parts of this segment. Like if I wanted to just talk about this piece right here, I would say AB and I'd put the segment symbol above. Or if I wanted to just talk about this piece, I would say BC and I'd put that symbol above. If I wanted to talk about this whole thing, I'd have to say AC and put that symbol above. So this is the symbol that means segment. When we talk about line segments as an object, and we're not talking about any numbers, and we just say line segment AB, you have to put that symbol above so that you know you're talking about a line segment. But if you were to take out a ruler and measure these, because line segments have a finite length, they don't go on forever, you could measure it. There's just a little subtle difference in the way that you name the line segment. So when talking about the length, which is to say you're using numbers, you drop the bar symbol. So if I wanted to take out a ruler and measure this and say how long segment AB is, I would write AB equals 3 centimeters, just like that. I don't need to put the symbol above it when I'm talking about how much it measures. I could say BC measures 7 centimeters. And then if I wanted to do some arithmetic, which means I'm doing something with numbers, again, I would not use the bar symbol. So I would say AB, which is this piece, plus BC, which is this piece. When you add those up, you get AC. And this is an equation. Numbers would go here. 3 is what I know AB is. 7 is what I know BC is. You add those together, you get AC, and so AC must be 10 centimeters. If you ever just see something written where you have two letters like PQ equals 14 inches, the fact that there's no symbol here doesn't mean that this is ambiguous, or doesn't mean that you don't know what it is. The fact that there's no symbol and that there's a number here, this means this must be a segment. And the next category based on movement is one where you can move in two directions. So if you can move in two directions, that means your object has length and it has width. And together that means it has area. And objects in this category are considered two-dimensional objects. Now, if your object has no start and no end, then that, and your 2D object, that could look like this. People usually draw it where it looks kind of like a sheet, like you're looking down at an angle at a sheet of paper, and the sheet has no start and no end, so it extends forever in that direction and forever that way and forever that way and forever that way, but it doesn't move up or down out of this surface. You can move anywhere in here, and you can keep going this way, and you can keep going this way, and you can keep going that way and that way, but you can't move up this way or down through the page. One of these is called a plane. But if instead of having no limit, we say, yes, there is a start, and yes, there is an end to your 2D object, then you get these, like a triangle, or one of these, a circle, which is a collection of points. Everything you see here is a point. Even though I didn't bold any of them, every bit of pencil you see here is a point. And what makes an object a circle, what's special about a circle, is that all of these points, collection of points, all the same distance from the center. So that distance is the same as that, distance is the same as that, it's the same as that. And these are just two examples of what we would call 2D shapes. And now last but not least, if you can move in 3 directions, that means you have length, I'll say you have length and width and height, which means your object has volume, and you should probably be able to guess now these would be called 3-dimensional objects. They can fall into 2 categories also. One where there is no start and no end. And I don't even, that's kind of hard to draw. We just have a word for that. It's space. It's everything. It's you taking your hand and waving it all around, forward, backward, up, down, swinging it around. You can move it anywhere. There's no limitation on how you can move. Like I can take the tip of this pencil and just move it everywhere. Up, down, forward, backward, left, right, diagonal, everywhere. That's space. Space lets you move everywhere. If we say, yes, there is a start and yes, there is an end to our 3D object. Then we get 3D shapes. And depending on how we limit the movement, we give them special names. Like this one is a cylinder, or one of these is a sphere, or one of these we could call a cube. And the last thing we're going to talk about is angles, which are formed by two intersecting either lines, rays, or segments. And depending on how they intersect with each other, we could put those into some categories and then give them names. So if when your segments intersect, they might look like this, or they might look like this, or they might look like that, or they could look, imagine here's one of them and then here's the other one, and so the angle is right there, or they could look like this and then like that, and I want to talk about that angle right there. In this case, you have an angle that is under 90 degrees. This case, your angle is 90 degrees. In this case, you are over 90 degrees, but you are under 180 degrees. In this case, your angle is 180 degrees. And in this case, you are over 180 degrees. This one we call an acute angle. This one is a right angle. We call these obtuse. If you make a perfectly straight line and you measure 180 degrees, you are still an angle, and you are called a straight angle. And if your angle swings to 180 and then keeps going so that you're over 180 degrees, you are called a reflex angle. And for any angle that you're going to talk about, you need to be able to name it. And the way we name angles depends on what the picture looks like or the figure looks like. So if your figure looked like this, and you knew, let's say, these 3 points, everything you see here is a point, but this one is special because I know it and its name is P. This one is special, I know it, its name is Q. And this one is special, its name is R. They all form an angle right here. This side comes together with this side. The sides meet at this place here called a vertex, and they form an angle. When I name this angle, I have a couple options. I could say angle P, R, Q. So I've explained how you trace this angle out. You start at P, you go to R, and then you go to Q. I also could have said start at Q, go to R, and then go to P. Or in this case, it's also okay to just say angle R because there's only one angle R there. But if in this exact same figure you wanted to refer to P, R, Q, you wanted to refer to this angle outside, this big angle, you would use all these same names, but you'd have to use this word reflex to say, I want you to go the long way around. So this would be reflex angle PRQ, or reflex angle QRP, or reflex angle R. And naming angles this way is perfectly fine when your figure looks like this, but in a situation like this, you have to be mindful of one issue. I'm just bolding the points here that are special because I know them. And let's say I wanted this angle right here. So here's one side, here's another side. B is the vertex. When I go to name this, I could follow these rules that I followed here. Like I could say start at E, go to B, then go to D, and you are an angle. That's fine. Or I could say you're an angle, start at D, go to B, then keep going and go to E. And then you might be tempted to say, or just angle B. But the problem with this, and the reason you can't do this, is because there are many angles present at the vertex B. If you just say angle B, you go to look at the figure, and I don't know if you mean this angle, this angle, this angle, or this angle. There are 4 angles here. There's actually more, because you could say this whole thing here is an angle, it's a straight angle, or this whole thing is a straight angle. But clearly, if you just say angle B, this is unclear. And so in this situation, you need 3 letters. But one thing you could do to get around this is you could add some more information to the picture, to your figure. Like if for some reason you didn't feel like writing 3 letters, although you really shouldn't have much of a hard time doing that. But there are cases where it does become easier if you label things differently. You could go into your figure and say this one right here, that's going to be angle 1. This one right here, that's going to be angle 2. This one right here, that's going to be angle 3. And this one right here, that's going to be angle 4. And then I know angle 1 is right there, angle 2 is there, angle 3 is there, angle 4 is there. And you can use these symbols and this notation in whatever you're going to write about or do.